Hello class, this is a video tutorial on combinations part 3. In this video we'll be looking at proofs and identities using combinations. Using the definition of a combination, n choose r equaling n factorial divided by n minus r factorial times r factorial. We will need to show certain expressions are equivalent or identical to other expressions. Below this is going to be numerical examples of the following general identities. So these three we will later be using extensively, and we'll actually be required to prove them in the exercises. But the way that we'd like to think of these is similar to trig identities, if you can recall these ones. These three are similar to the core trig identities, but for probability and binomials. We'll be using them very extensively in these, especially for this one, binomial theorems. So let's get straight into some examples. I've copied for us the definition and the three identities we're going to be solving later on in the exercise. Just so you know, these first two exercises will help you solve the first identity. The next two will be this next one, and this last one, these last two, will help you solve this one here. Now at any time you can pause and try solving these yourselves. So let's get straight to it. Now, similar to trig identities, what we do is we worked on the left hand side first, and then we work on the right hand side and make them equal to each other. Oh, sorry, let me rephrase that. In trig identities, we try working with just the left hand side to make it look like the right hand side, but with binomial theorems, we sometimes have to work with both. So let's do this. 15 choose 7, using our identity, well, the definition, sorry, it's going to be 15 factorial, as shown here, divided by this one here, it's n minus r, so 15 minus 7, that's going to be 8 factorial, and then r factorial, so 7 factorial. We can't simplify this any further. This is our left hand side. For our right hand side, 15 choose 8. Sticking to our definition, 15 factorial over n minus r. N minus r, that's 15, take away 8. It's going to be 7 factorial times 8 factorial. Because this is multiplication, we can multiply them in any way that we like. So we could very well rewrite this as 15 factorial over 8 factorial times 7 factorial, which is equivalent to 15 choose 7. And that's our proof. So you can go ahead, pause the video, and try it yourself for this one, because I'm going to solve this rather quickly now. So here we go, 3, 2, 1, let's go. 11 choose 2, that's 11 factorial over 9 factorial, 2 factorial. This one here, 11 choose 9, is 11 factorial over 2 factorial, 9 factorial, which we can just rearrange as 11 factorial over 9 factorial, 2 factorial, which is equal to 11 choose 2. And there we go. So you can try it yourselves and try and solve this one using general terms. We'll be doing that in a different video, solving this without using numbers. So let's go straight into the next one. move this up. Here we go. So 18 pick 7. Let's use the definition of this, if we can recall it. Essentially, with pick notation, it's the exact same thing, except we ignore that r factorial at the end. So this is going to be 18 factorial over 18 minus 7, as shown here. 18 minus 7 is 11 factorial. There's no 7 factorial because that is used for choose notation. For pick notation, we do not include that. So we're done with this notation here. Let's now take a look at this other expression. 7 factorial times 18 choose 7. So let's try and write that one out. 7 factorial times 18 choose 7. That's equivalent to 7 factorial times, using our definition here, 18 factorial over n minus r, so 18 take away 7, which is going to be 11 factorial times 7 factorial. If we write this, we can think of this as a fraction over 1. Well, hopefully you already saw that. This is going to become, writing it out, 18 factorial times 7 factorial over 11 factorial times 7 factorial. Because these are multiplication, we can ignore those, or sorry, not ignore, we can cancel those, meaning that this here is equal to 18 factorial over 11 factorial, which is equivalent to 18 pick 7. And there is our proof. Okay, you can go ahead, pause the video and try it yourself for this next one here. So, using the definition of pick notation, that's 9 factorial over 9 minus 3 is 6 factorial. This right hand side is going to be equivalent to 3 factorial, using the definition of choose. It's going to be 3 factorial times 9 factorial over 9 minus 3 is 6 factorial times r factorial, which is that 3 factorial there. We can skip all these middle bits here because we can already see that it's going to cancel like so. That's 9 factorial over 6 factorial, which is equivalent to 9 pick 3. And there we have it for these two proofs. Well, by two I mean these two. In the next video, because they're much longer, I'm gonna see you in the next video where I show you how to prove these two, which will hopefully help you in proving this one yourself. So I'll see you in the next video. Best of luck.